Okay, everybody, here I am recording after having lectured you, but not being recording in Zoom. So the work is already done here. Here's the example we started with where I asked you to work on it on your own. And the first thing I did was solve for the difference quotient. And then it is one of the problems where we had to multiply by the conjugate in order to be able to simplify out the h that's in the denominator. So the work done there is the simplification of the difference quotient, and to find the derivative I took the limit as h goes to 0 and it ended up with a derivative of 1 over 2 times the square root of x. I then asked to write an equation of a tangent line at the point x1 equals 4. So the writing in red here is where we figured out what the y1 is that's going to go with x1 equals 4. And then we have the point slope form for the equation of a tangent line. To get the value of the slope, now that we have the x1, y1, we plug the x equals 4 into the derivative and get a slope of 1/4. And then I just plugged into point slope form. And finally, I solved for y to get it in y equals mx plus b form. After that, I discussed other notations for writing the derivative. So f prime of x, y prime, dy dx, and df dx are all correct notations for stating the derivative is this. So if you write any of those equals some function, that tells me the derivative is whatever you have written on the other side of the equal sign. If you have d dx of something, that's a command saying take the derivative. When it comes to slope, the notation we used in the last example to find the slope is we plug in the value of x we're interested in this case I'm calling it a, into f prime of x and get a number. That is the slope of the tangent line at that point a. Another way of writing that is dy dx given x equals a. That vertical line is given. Okay, that's it for this slide. I'm going to go make another recording just so that you have the slide on differentiability and continuity.